Hello and welcome to another video. In this video we're going to be working on patching array, and in this one you're given a sorted integer array nums and an integer n, and you can patch elements of the array such that any number in the range can be formed by the sum of some elements in the array. Return the minimum number of patches needed. And so in here nums is 1 through 3 and n equals 6, and then there's 1 here, and this is so you can basically make everything. So if we take a look, if we have 1 and 3, we can't make a 2, right? So we have to be able to make everything in the range of 1 to 6. So we can't make a 2, so we have to add a 2. Now we can make 1, 2, 3, we can make 4 like this, we can make 5 like this, and we can make 6. So that's all we need. In the second example, we're trying to make everything in the range of 1 to 20. So we have a 5, a 1, and a 10. So we can't make a 2 for sure, right, with these numbers, so we have to add a 2. Can we make a 3? Yes. Can we make a 4? No. Can we make a 5? Yes. 6, 7, 8, 9, 10, and so on. And so you can actually make anything up to 20 here. So the main thing you have to know is, like, if I can make something in a range and I add a number, like what range do I cover now, basically? And that's kind of the idea for this problem. And also note that if I can make something in a range and I can add a number, that range will increase. But if I'm not covering something, then I'm not going to be able to make that. So for example, if I can make something in the range of 1 to x, and I add y, and I'm missing a number in between x and y, I can't make that, right? Because if I'm able to make, let's say, numbers 1 through 10, and I add 50, there's no way I'm going to be able to make numbers 11 through 49, right? Like how would I do that? I can't. But the range, when you have a range that you cover and you add another number, so let's just show this. Like what range do we cover now? So if we covered 1 through 10 and we add 50, we can take all of these numbers and add 50. So now we cover 1 through 10, and we also cover 51 through 59, or 60, right? But we're still missing all of this. But let's say we are trying to cover this whole thing, right? Like we're trying to cover, let's say n is like 70 or something here. Or let's say it's 60. What other numbers do we have to add for sure? And let's see what happens into this whole thing. So let's actually go back, and let's actually have an array of numbers that we have, that we cover everything, and then let's see what we're missing. So let's say here n equals 60, and let's just have some numbers and see what we need to add. So let's actually maybe go through this example. So maybe let's say we have 1, 5, 10. So we have 1, 5, 10, and we probably don't need these indices. Yeah. So we have 1, 5, 10. So the basic idea is, the way to do these kinds of things is, as long as you can cover 1 through x, and you add y, and y equals x plus 1. Now you can actually cover the range of 1 through x plus y. So hopefully that makes sense. And because, let's go through an example. Let's say we can cover 1 through 10. So if we can cover 1 through 10, the only way to make 11 is to add 11 now. Because we can, like, as long as we don't have duplicates. Now, obviously, like, let's say there's actually other ways to make 11. There's other ways to make 11 because we could add another number in here. But one of the ways to make 11, just by adding one number, is to just add an 11. And now, if we covered 1 through 10 and we also add an 11, well, now we covered all of these. So if we just add 11 to all of these, right, we would be able to cover then 11, and we'd also be able to cover 12 through 21. So now our new range would be 1 through 21. So the basic idea is we can just go through all of our numbers that we have and keep adding them to our, like, numbers that we could cover. And as long as the number we're adding is one greater, like as long as we're not missing anything between this number and the one we're adding, then we're good. And I'll kind of show you what I mean here. So let's get rid of all of this. So first we check, like let's say our starting range can only cover 0, right? So our range can cover 0. And our numbers are sorted. So let's say we're trying to get to 60. And we're trying to figure out like what do we need to add. Okay, well, so the first number we need to have is a 1. So we just check like, is our smallest number a 1? Yes, it is. Okay, so then we know we can cover the 1 and we already have it. Then we can cover our range that we can cover now is 1 to 1. Now can we cover 2? So we already use this number. So now we go over here and we say like, is this a 2? Like, can we make a 2 somehow? No, we can't. So we know we have to add a 2. So we have to add a brand new number that's a 2, and we'll just move these over. So let's say we add a 2 here. This will be our new added number. And then we have our old numbers of 5 and 10. And we added a 2. Now the range that we can cover. So we could cover 1, we could cover 2, but we can actually add these now. Because we're covering numbers that are in order, we can actually add these. So the range we can actually cover now is 3. Because like I said, if we can cover 1 to x, which in this case, x is 1, when you add y, that's x plus 1, now the range you can cover is 1 to x plus y. So the range we can cover is 1 through 3. Then we look, we've already used these numbers, so then we see like, okay, the next number we need is a 4. Is this a 4? No, it's not. So we have to add a 4. So 4, new number, and then we move our 5 and our 10. So we're going to add the 4 over here, and our 5 and our 10 come over here. Well, let's actually keep this in the same color, like this. So we added 2 numbers. We're going to keep this in blue. And now the range we can cover, so our old 1 through x was 1 through 3. We added a 4. Now the range we can cover is these two together, so 1 through 7. So this is 7. Let's just actually get rid of this whole range thing. We'll just use this. So the range we can cover is 1 through 7. Now we're seeing if we can cover an 8. We've already used these numbers. Now we get to a 5. So what happens if the number we're adding is smaller than the range we can cover? So if the number we're adding is smaller than the range we can cover, so I guess formally, if y is less than or equal to x plus 1, then our range extends by y, right? And we're not missing anything else. So like if we can cover 1 through 10 and we add 1,000,000, then we can't cover anything from 11 to 1,000,000 minus 1. But if we have 1 through 10 and we add a 5, or 1 through 7 and we add a 5, now our range actually extends to 12. And that's because if we could cover 1 through 7, we can just take, like to get 8, we just take one of our old values we could cover and add a 5, which would be a 3, right? And then to get 9, we can get 4 plus 5, we get 9. 10, we'd get an old 5 plus 5. 11, 6 plus 5, and 12, 7 plus 5. Because we could cover those, right? So hopefully that makes sense. Since we can cover 1 through 7, we can take any one of those old values and add a 5, and that's our new range. And so the most we can cover now is 1 through 12. Okay. Now we come over here, and we're looking for a 13, right? Because we have to get to 60. But we have a 10. So same thing. If we can cover 1 through 12 and we add a 10, now we can cover 1 through 22. Because if we could cover 1 through 12, we can just take all those numbers, add a 10, and now our new range is 1 through 22. And we don't have to add a 10, right? So we could cover 1 through 12, but now we can also cover 13 through 22 just by taking our old 1 through 12 and adding a 10. Okay, now we come over here, and we have no more numbers. And we need a 23. So we're missing 23, so we actually have to add 23. So it's kind of like if you're missing a number that isn't in your array, then you have to add it in. So let's say we were looking for 23 here, and our next number is like 50. That means there's no way to make 23. And that would make sense, right? Because this whole thing sums up to 22, or it should. So it's 19, 20, 22. Yeah, so this whole thing sums up to 22, and if we had like a 50 here, then there's no way to make 23. So we're basically like looking for the next number, and if we don't have it, then we throw it in. So we'll add a 23 in here. And now our next range is like, this is fine to add to our range because we're not missing anything, right? We covered 1 through 22. Now we add 23. So now we could cover 1 through 45. And as long as you're adding numbers that you're not missing, because this is our next number that we need to cover, now it makes sense why we can cover this range, because we can cover 1 through 22, and then we can take all those numbers and add 23, and that would give us 23 through 45, or 23 by itself would give us 23, and then to get like 24, 25, 26, and all those, you just take our previous range, one of those numbers, and you add 23 exactly. So now we can cover 1 through 45, so now we look through and we try to find 46. We don't have it, so we need to add it in, and it makes sense once again, because this whole thing adds up to, or it should add up to 45. So let's see, 33, 38, 45. Yeah, so obviously we can't make 46. So then we have to add 46. And now our range becomes big enough to cover 60. So that's kind of the algorithm, is you write down your initial range, and then you just write down, like, what's the next number I need? So if my range is 0, I need to have a 1. If I don't have it, I don't need to add it into the array. I can just increase my current range by the number I'm missing and add that number as the number I'm missing. So we don't actually need to add these to the array. So basically what we'd say is like, okay, we need a 1, we have a 1. We need a 2, we don't have a 2. So that's one more number to add, and our new range is the 1 plus the 2, which is 3. Then we have then the next number we need is a 3, which we have. But we don't need to actually look through like the next number we need one by one by one. We can just check what are the numbers in the array. Actually, no, we should look at the next number we need. So we look at the next number we need, and we look at the next number in the array. So in this case, the next number we need is a 3, but we have a 4. Actually, the next number wouldn't be a 3 because our old range was a 3, right? So what would actually happen is we would need a 1, which we have. We would need a 2, which we didn't. So we add that in. Now our range is a 3. So the next number actually be a 4, which we don't have. Then we add that in. And then now our range would be a 7. So the next number would be an 8. And the next number there is a 5. And anytime your number in the array is within your range or the one after, you can just add in directly. So our new range would be 13, I think. And then we can add the 10 as well. And our new range would be, I think our actually be 12. Yeah, our new range would be 12. And then we have the 10, which we can add into our range. And then our new range would be 22. Then we're looking for 23, which we don't have. So then we add that in. And then our new range would be 45. And then we look for 46, which we don't have. And then our new range would be like 91, which covers the 60. So that's kind of the algorithm, is you just look for what's the number you need, what's the next number in the array. If the number in the array is within your range, add it in. If the number you're looking for is too small to be in the array, then you need to actually add it in manually. And that's what we're going to do. So we can code it now. Hopefully that makes sense. So I actually didn't realize the array was sorted at first, so I actually sorted it, but it's actually sorted. And this has to be sorted to work. Because like if you're looking for a 1, you need to check the small number first. So you're kind of like building up your range from the smallest number first. So we need a couple variables here. Maybe we'll have a range. And we'll just say we cover 0 for now. We have a result, which is like the number of numbers we added. And we'll have an index in nums. Now we'll say while our range is less than n, right? We need to cover n or more, 1 through n or more. So we're going to first check if we're out of bounds in the array, like maybe we don't have any more numbers. So if index is out of bounds, or the number we're looking for is smaller than the number in the array, right? So let's say our range is like 1 through 9, and the next number we're on is like 23. So if our range is 1 through 9, we're looking for a 10. So if this number is not 10 or less, then we can't take it, and we have to add more numbers until this number is fine. So we can say, or range is less than, and this is going to be nums index minus 1, right? So you can take, like, if our range is 1 through 9 and we have a 10, that's fine. We can take that, and we won't be missing any space. But if our range is 1 through 9 and the number is bigger than 10, then we have to add numbers in. So it's like this. And to add a number in, we will increment result. And the next number we're going to be adding in, so if our range is 1 through 9, we have to have a 10, so we'll add in whatever the next number is. So range plus equals range plus 1. Right? So if we covered 1 through 9, we have to add 10. And we keep doing that until the number in the array is now valid to add into our range without adding in more numbers. Otherwise, we can just add the number in the array directly, because if our range is 1 through 10 and we have a 5, we can just add the 5 in directly because we're already covering anything, we won't have any gaps. So if we add a number in directly, then our range extends by nums. Yeah, our range just extends by nums index, and then we increment the index that we're on now. And I believe that is it. So let's see if that works. So hopefully that makes sense how this works now. If you are able to cover a range. Oh yeah, there's one more thing. So technically n here is like I think the biggest integer is like 2 to the 32. So even though n is within an integer, the range you can cover might actually be bigger than n because you're going to be adding a number. So you just need to use a long here instead of int. And then we shouldn't get an overflow. Okay. And there we go. So hopefully that makes sense. I think I did a LeetCode contest problem that was basically this. It was a medium problem. And I did a explanation on it. So I'll link that one as well. It's basically the same thing as this, I think. So and I have like a page that I wrote on it. So I'll link that in the description. So for this is of n time, because we're basically actually, so it's not quite O of n because we're adding number, like let's say our array is empty and n is like some huge number. We have to keep adding numbers to get to n. And so the number we're adding, like if you think about it, our range is basically doubling every time, right? Because if our range is 1 through 9, we're adding the next number. So we're adding 10. And then our range will be like 19, and then we're adding 20. So our range is doubling and doubling and doubling and doubling. So like it's going to be n plus log of this. So it's actually going to be like of length nums plus log of this n over here. Like this. Because let's say the array has nothing and n is some big number, our range is going to keep doubling and doubling and doubling and doubling, which is logarithmic. And we might have to go through all the numbers as well. So it's going to be both of those. And then space. So I think we just have constant space here. Yep. Okay. So that's going to be all for this one. Hopefully it was helpful. If it was, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.